Hello, this is a presentation on the application of electrostatics on laser printers by Hua Zhong. We all have witnessed some interesting phenomena that include some objects, such as styrofoams or bits of papers, sticking onto one another objects without any glue or other materials that would usually allow the materials to stick to one another. However, these objects just stick to one another, and that is due to the principle of electrostatics, which we examine electric charges or fields as opposed to electric currents. Scientists, including well-known individuals such as Benjamin Franklin and Charles Coulomb, have experimented on and helped us to understand electrostatics, and now we can use the principles to make useful tools in our daily lives. Among these tools is the laser printer. It shares parts that other traditional printers have, including paper trays, toners, paper exits, etc. What makes this printer innovative compared to the previous version of the printers, that its graphics output is much more accurate, is thanks to the use of electrostatics. The parts in the laser printer, called the laser unit, corona wire, and the photoreceptor drum assembly, helps with application of the electrostatics to print fine outputs. So this is how the laser printer operates. Bytes of data to be printed are streamed into the printer from the PC. The printer then converts these data into the format in writings and pictures that we may understand. Then the printer's circuit activates the corona wire to create static charges to its surroundings, including the photoreceptor drum, so that the drum gains a positive charge spread uniformly across its surface. The circuit then activates the laser to make it draw images and text onto the drum. Where the laser beam hits the drum, it erases the positive charge that was there and creates an area of negative charges instead. Gradually, an image of the entire page builds up on the drum. Where the page should be white, there are areas with a positive charge. Where the page should be black, there are areas of negative charge. An ink roller touching the photoreceptor drum coats it with tiny particle of powdered ink, aka toner. The toner has been given a positive electrical charge, so it sticks to the parts of the photoreceptor drum that have a negative charge. No ink is attracted to the parts of the drum that have a positive charge. An ink image of the page builds up on the drum, then the ink written drum is now printed onto the paper to get the desired prints. The principle of electrostatics applied here includes the fact that static electricity is simply an electrical charge built up on an insulated object. This includes corona wire charged up with high voltage to create some sort of polarity, as in spreading positive charges only onto the photoreceptor drum assembly, and using the principle that the opposites attract to have the laser to shave up positive charge area into negative charge areas, and have the ink toner charged positively spread ink to the desired parts of the drum, so that the contrast on the drum is printed onto the paper with much precision. As conclusion, we have examined how such a useful everyday object in our lives function with simple principles of electrostatics, the same phenomenon that explains our hair and styrofoams to stick to a balloon. Thank you for your participation for my presentation.